Good afternoon. How's everyone doing? We got a fun one for you. Do we have any space nerds in the room? Oh my God. Space nerds per square inch is very high. Trekkies too, all right. Yeah, no, I think this will be one of the more interesting sessions that you'll go to here at reInvent. We're going to tell you how we did a live production from space in 4K. And so we'll go through some, we're lucky enough to have some folks from NASA here. We have both Rodney and Dylan from NASA, and they'll come up and give you a little bit of background and history. And then I'll come back up and talk a little bit about the process of getting an encoder. Any video nerds? You're mostly NASA, mostly space. That's cool. We'll keep it light. It is a 200 session after all, but hopefully it'll spark your imagination a little bit, and we'll just walk you through how we did it. We did it at the NAB show, which is the largest broadcaster show. It's actually about 2 to 3 times the size of reInvent in terms of its attendance, and we'll just walk you through that whole workflow. It's a great combination of essentially resources that are almost in a data center, probably the world's most expensive data center, I would call it, on the ISS, and the use of the cloud, okay? And so you'll get this idea of the blend. The company that was behind it, so we're part of AWS. I'm the chief marketing officer of a division within AWS called AWS Elemental, and we are very focused on video, core video technology. And just on Monday, we announced a new category essentially in the console for 5 media services. And so that is basically bringing a lot of the capabilities that we've created for companies all over the planet and bringing those to the AWS management console. So if you are a video nerd or a video geek, feel free to try that out. And before we get into it, I want to just start with a real brief quote. Galileo once said, "If you could see the earth illuminated when you were at a place as dark as night, it would look more splendid than the moon." And so to get the juices flowing a little bit, I want to show you a little video here, and then at the end of it, we'll have the folks from NASA come up and start to talk about it. Oop, went back. So Galileo had to rely on his imagination to envision the possibility of viewing our beautiful planet from above the clouds. Half a millennium ago, after Galileo, this isn't just a possibility, but it's a true reality. We can bring the music up a little bit. The International Space Station is a collaboration between 5 international space agencies. It hovers about 400 kilometers above the planet, and it's going at 25,000 kilometers per hour. It'll orbit the Earth in around 90 minutes. It's been continuously inhabited for over almost 2 decades, and has had about a dozen different countries participate. If Galileo were here today, he probably wouldn't be able to get on the ISS because of the billions of people that have been alive. Only 400 have spent any amount of time in space, but we can all see it with video and pictures. So please welcome Rodney and Dylan from NASA.
So I know a lot of you are going to be tempted to look at your phones for various reasons, so I'm going to give you a reason to do that. Earlier this year, we finally were able to consolidate a lot of our imagery galleries and make them more accessible to you, the public. And if you want to check that out, it's built in the cloud using AWS services, and it's at images.nasa.gov. So if you've never checked that out and you feel the need to get your own NASA imagery, since the American taxpayer paid for it, we thought it'd be a good idea to make it a little bit easier for you to find it and access it. So images.nasa.gov. I'm going to talk a few minutes about why NASA creates imagery in the first place and how we use it. There's more than just pretty pictures involved oftentimes. If you think about it, NASA is a very unique creation within the government. We're one of the only agencies in the government that from its very inception had in its charter, and it remains in its charter, that everything that we do is the property of the American taxpayer. And in that charter, it tells NASA, make all of that data accessible to the public. I'm paraphrasing, much longer sentence than this, but the gist of it is, make it available to the public in the most efficient means possible. And so imagery, if you go out on the street and just ask a person, tell me something about NASA, or if I ask you right now, what do you think of when you think about NASA, it's probably an image or imagery that pops in your head, right? An iconic image in space, or of human space flight, or the Earth from space. So if you look at why NASA creates imagery, there's scientific and engineering reasons for it, but there's also the inspirational part that comes out of it as well. So from its very inception, we've been documenting what we do, using that imagery for scientific and engineering purposes, but also making it available to the public. This is the first photo by an American in space. Who was that? Al Shepard, very good. All right. Fired off in a short little ballistic missile trajectory, if you want to think of it that way, off the coast of Florida. About a 15-minute ride in space in a little tiny capsule. This was the first photograph that Al Shepard was able to take. So one of the things that drives me absolutely crazy are the conspiracy theorists who come up with all kinds of explanations or tries to come up with explanations. And one of the ones that drives me the craziest is, why are there no stars in the pictures of the moon? Well, let me ask you this question. Those of you that are photographers, when you take a picture of the moon from Earth, can you see any stars? How much do you have to stop down? How bright is that? Can you imagine how bright it is if you're standing on the surface of the moon? So a lot of those photographs were taken by the astronauts themselves. They had a Hasselblad camera on their chest, and they would have to look down in that visor of theirs and try to frame it and click this clunky button to take these pictures using roll film, these large rolls of film. I've actually got to see where those rolls of film are kept. They're inside a double frozen vault at the Johnson Space Center, and every so often they're pulled out and redigitized with the newest and latest technology. This is one of my favorite images from a space probe. Now, this is slightly enhanced, I will tell you. The blue halo and everything is enhanced a little bit. Not sure how well you guys can see it, but there's a little blue dot there, and that's us from Saturn. One of the things that I love about NASA imagery is that it gives you a little bit of perspective and humility sometimes. You know, there's an image like this on my computer. When I go to work every day, I'm confronted by a photograph very similar to this. You are here, and it just sets me for the rest of my day to remind myself that we're on this precious rock floating out in the vastness of space, and if there's anybody else out there or any other creations out there, they're just seeing this blue dot, just like this. Here's a selfie from one of our rovers, the Curiosity rover. This thing's the size of a Mini Cooper. When I got to see it before it flew at JPL, I thought they were crazy. You know, you guys are actually going to fly something this big and drive it around remotely on the surface of Mars. The imagers on these probes are a mixture of commercial technologies and special sauce technologies, but one of the things that we struggle with is radiation damage. When you get outside of the low Earth orbit, where we're protected from radiation, and you get out into deep space, those protons, those ionizing protons that are out there, from gamma rays and other sources, they will damage everything, the human body and all of the electronics and so forth. And so The imagers that we fly on Mars have gone through lots of design changes from the cameras that we all carry around to try to protect them from radiation damage, and they're manifested by dead pixels. So if you are watching NASA television from time to time, and you look for white dots in the video, those are damaged pixels on the HDTV cameras. And rather than spend millions of your dollars to design a camera like the one that has to work in Mars, since we can go to the space station every few months, we just buy commercial HDTV cameras. The ones we fly are Canon 305s, and every 8 months we fly new ones. A whole lot cheaper than spending millions of dollars for a camera that is radiation tolerant. But look for those white pixels. This is an image of the entire space station taken from the space shuttle, I think, Dylan, is that right? And it gives you a sense of the vastness of this platform. What makes the space station now very relevant for us, and if we have time later, we'll talk a little bit about this, is it's a laboratory that we can use to test out the technologies for us to go and explore deep space, leave low Earth orbit, go back to the moon and use it as a testing ground, a proving ground for the technologies that we need to take humans onto Mars. And so over the next 4 to 5 years, we're going to see a shift in some of the work being done on the space station to get us ready for the Deep Space Gateway, which NASA's planning in the 2020s, which is going to be a smaller station in orbit around the moon. And from that station, we will build the deep space transport vehicle. So Dylan's going to talk a little bit more about the space station, and if we have time at the end, if anybody's interested in talking a little bit more about our plans in deep space, we can talk about that.
Good afternoon, I'm Dylan Mathis. I'm the Communication Manager for the International Space Station program. A quick question. How many people are in space right now? How many? How many people are outside of the Earth's atmosphere on the International Space Station? No one's ever done that. That was good. That was good, by the way.
Like 6, 7.
6. Very good.
Somebody made an API query.
Right. So we have 6 astronauts and cosmonauts on the International Space Station right now. And we have had a permanent presence on the International Space Station for 17 years this month. Uninterrupted, continuous crew, living and working in space, so that we can do research that we can't do anywhere else. A little bit about the space station, first of all. It's about the size of a football field, so it's pretty big. It's the largest thing that orbits the Earth at this point. Very, very big. It's about the size of a 6-bedroom house. It also has more volume than a 747. So you've got 6 people in this 6-bedroom house for 6 months at a time. It's quite impressive that they all live and get along and work so well together. It's not just the US and the Russians that are on the space station. We've got 5 space agencies involved. The European Space Agency, Japanese Space Agency, Canadian Space Agency, and then Russia and NASA. The European Space Agency obviously has a handful of the European countries that we work with as well, and that is under what we call ESA, the European Space Agency. So fast forward a little bit to 2006. This is a shot taken from Times Square. We did the first live high-definition downlink from the space station in 2006. It took an amazing amount of time, effort to do. The cost to certify a camera to fly in space the way NASA used to do things took a lot of time and money. I mean, it was, millions of dollars and took 18 months to get into space from beginning to the actual event occurring. So this milestone was very significant, not only from a broadcaster's perspective, but from a NASA historical perspective. But NASA is drastically changing the way that it's doing business. And we teamed with AWS Elemental to do the first live 4K downlink from space. If you see in the first picture here, there's the encoder and a red digital cinema camera. So we had this idea, we said, we can actually use this red camera that we already had on the space station, and Elemental took all the smart people that they have and probably even more. It's amazing, they got it down to something that's the size of a set-top box that actually encoded the video using H.265. They were able to work with the NASA folks and get this certified in 29 days. So remember earlier I said 18 months. Now we were down to something in 29 days that was ready to go to space. It flew, ironically, out of Japan in Tanegashima on a cargo vehicle that went to the space station. And there you can see it being berthed to the space station, and then it actually was installed and tested in January of 2017. And you can see my buddy Brian here is very excited in Nerdville over at NASA, where all of the downlinks come in from the space station. The test was very successful. We got live downlink, 4K, everything worked. So we said, well, we want to take this to the public. We want to show folks how all of this works. And we teamed with Elemental and National Association of Broadcasters to do the first live 4K event from the space station. After that, I'd like to turn it over to Keith.
Am I on? Okay, there we go. So we're going to walk through, just imagine we have a 4K camera and there we go, and a small form factor encoder, which before this point in time had been roughly 4 times the size. But to give you a feel for what we actually did, what we've done is we did about a 45-minute or so production in a ballroom kind of similar to this, where our CEO, who actually tragically passed away after this event, it was something that he was very passionate about. He was passionate about space. He was super excited. You'll see how excited he was. This is one of the last public appearances, really, that he made. And so I want to just acknowledge that, because he really drove a lot of along with NASA, the impetus for this program. But you'll see him here basically doing an interview, and we've spliced it down. So the whole thing was about 45 minutes. The interview was about 15 minutes, I believe. And so we've brought it down to about a 2-minute clip. There's some flashing in there that's just associated with the editing, but this will give you a feel for what we actually did in terms of production, and then I'll talk about the workflow in terms of how we did it.
Who's excited? First live 4K transmission from space ever.
Hey, this is Houston. Are you ready for the event?
Yes, we're ready for the event.
What is the ISS position in orbit right now?
Well, we're just passing over Baja, California, and we're heading in an arc over North America. By the time we finish talking, we'll be over Central Africa.
Wow. Amazing, amazing. Now, of course, we're calling from the NAB show here in Las Vegas, where next generation broadcast and production technology comes to life. Are there any films about space that have truly inspired you?
Well, for me, it was definitely The Right Stuff. As a test pilot who, Edwards was my second home. The start where he's like flying through the clouds and he's talking about there's a demon that lives on the meter. And then the plane crashes, it explodes, it goes to color. That's just so awesome. And then also Spaceballs, because we're basically flying at ludicrous speed right now.
Yeah, okay. What do live 4K and Ultra HD help you do on board the ISS in terms of scientific research that you couldn't do before?
4K and ultra high def actually make you feel like you're there. I mean, if you look really close, you can probably see into my pores right now. Granted, nobody wants to see there, but everybody wants to see the Earth from this vantage point. And probably the biggest impact that these technologies will have is bringing everyone else on the planet to see these amazing sights that we get to see every day and inspire them to push beyond just living on Earth.
And we're going to play ping pong.
Oh.
And a little food coloring added to that.
Peggy, Jack, I don't know if you can hear the oohs and ahs in the audience here, but it's tremendous. Congratulations on all your accomplishments, and we look forward to a lot of live 4K UHD from the space station for years to come. Thank you.
So you can see they were having fun there, and I have to do a disclaimer. That was our old AWS logo on that, but we did this back in April, and so we changed our logo in September. So I have to do that disclaimer. Let me tell you a little bit more about what we were doing there. It was a very high pressure situation. Doing a live interview with folks on the space station has become, it's not commonplace, but it's typically done in HD level of video. Doing 4K, have folks looked at 4K in the home streamed yet? Anyone raise your hand if you've watched, about 20%. Doing that as a live source with a live interview from space, super high risk, okay? And hopefully that gives you a little bit of a feel for what was going on. Sam was basically on stage like I am right now, talking to two astronauts in space while the video was coming down so that we could see that. And then we were doing a live production where we put those feeds together and then delivered it out over the internet. So you're hoping that they're going to stay this happy, because when it goes, I'm sure they would have been great if it had gone south, because I'm sure they're trained for that situation. But we wanted to make sure they were happy. I wanted to make sure my CEO was happy. We had customers, we had viewers all over the world that were watching this, and this production was definitely high octane, and the sound in the audience. I saw a little bit of it here when the guy floated by, like, okay, that's real. We talked earlier about how annoying it is when people talk about space being, fake and all these conspiracy theorists. Literally, when we were doing this live, there was a production that was being created to dispute everything that we were doing. We're like, God, you have to have better use of your time than that. What I want to do is just walk through essentially some of the challenges that we overcame so that you can see kind of what you can do when you put your imagination to it. Doing 4K in space, we've talked about it with the encoder. I'll go into a little bit more detail on that. Making sure that everything end to end had full redundancy as much as we could. Now, there were some limitations. I don't think we had 2 cameras, right? So there's really serious weight and space constraints, as you can imagine. So that could have been a single point of failure. It's possible that the encoder could have failed. We did have a backup that could have brought it down to HD, and then we wouldn't have had such an exciting event or proof point. Testing, Dylan, I think, talked a little bit about the testing being done in 29 days. It was, for us, a lot of fun and excruciating, right? So they're testing not only the signal, not only the heat and making sure that we're not going to blow up the most expensive broadcast facility in the world, but we're testing things like, what if some dust gets into the fan on this device and goes into the astronaut's eye? What is the reaction that we're going to have for that? It was that level of detail. It was a several hundred checklist certification that had to go on. The bandwidth, making sure that we could reduce 4K down to, if you know anything about video, Typical source video is very high bit rate, very high bandwidth. Even for HD, it's usually compressed down by 1 to 200 to 1, and we were doing the same thing for the 4K, and then also delivering that 4K eventually, and you'll get a better feel for this when I go through the workflow, all the way around the world over the internet. And that's where the last mile comes in. We had to have backup situations for certain geographies that just don't have that amount of bandwidth. If they're not doing more than 10 megabits per second, then we're going to deliver an HD stream to those particular geographies. So, a typical encoder, AWS is a cloud company. You guys might be aware of that, and gals. But we also have physical things that we sell. So Snowball is an example of that, to ingest content that's really good for video files, actually. You see some devices that have been announced just in the last day to help developers develop for Internet of Things. We also have encoders. Encoders will typically sit in a venue for live processing. So we do the live NFL football on Thursday nights on Amazon Video. You'll be able to see that there. There are very often in venues these types of physical industrial gear, because you have to get it into the cloud with that encoder. We had to shrink it down. We had to bring it down basically to the size of a book, I would say, a little bit bigger than a paperback book. And then we used, wasn't Velcro invented by NASA? So, use what, eat your dog food. We put some Velcro in the ISS, and that's how the mount happened for this encoder. And so you can see it was very compact, lightweight, had gone through all that certification. Power was 180 watts, which is dramatically lower than a typical industrial grade system. And as Dylan said, we shot that baby into space, and we thought, wow, we're done. Not quite, but it felt good to get it up into space. And that was in December, just about a year ago, actually. And then we started thinking about the signal. Video for 4K is about it's 4 times the resolution, 4 times the information. We were using advanced compression techniques to reduce the bit rate to below 18 megabits, which is what we were allocated on the downlink from the ISS over the satellite feed. And we do a very good job of that, so that wasn't so much of a challenge for us. But we were able to make that happen and get that data down. So here's what it looks like basically in the ISS. We had a 4K camera, which is a red Epic Dragon there that was resident, had already been up on the space station. And we put the encoder in there and had a quad SDI input into that encoder to compress it in real time. And that created the downlink from the session. You can see here I think this is going to be a laser. You can see these are not astronauts because they don't have hands, okay? Just want to make sure everyone's not upset by that. They're just the suits waiting. And it's interesting that we put the camera right by the storage for the suits, keeping it company there. So at that point, the workflow gets a little bit more complicated. So we're doing a downlink from the ISS. We're bringing it down to Building 30, which is at the Johnson Space Center. One thing that was unique for this workflow is that embedded audio on the red camera was not something that was going to work. And so we actually we decided to send both the 4K feed as well as an HD feed. The HD feed was our backup, and that had audio in it as well. And so we were able to drop that down and then basically bring the audio back together again with the 4K signal. So this is the source. This is the astronauts doing their thing, being on video, and it's dropping down to the Johnson facility. It's being recombined with audio from the backup feed, and then we're sending that out to the Las Vegas Convention Center so that everyone here could see a video that's coming down in real time, essentially, from the ISS. So these are the two, basically, systems that are recompressing it and then sending it to our partner Encompass in Atlanta to go towards the Las Vegas Convention Center. You may be asking, Anyone know what POTS is? Plain old telephone service. Why were we using that? It's the actual feed of the questions that are coming back from the LVCC and then being set up to the astronauts. So one of the things that we did in the video that I showed you earlier, because gave you a compressed version of it down to 2 minutes or so, one thing that we haven't talked about here is the delay. Remember years ago when you'd watch the news and there'd be this delay between the person asking the questions and then the person answering? That was really real in this situation because we had quite a long delay, and Sam and the astronauts had to deal with that. So he was asking a question, keeping the audience engaged. When the astronauts weren't talking and were listening for a message, they were doing some fun things. So you saw them flipping the microphone, using elements of distraction a little bit to make the time seem short. Any guess on how long the delay was? 5 seconds? 2.5? It was 11 seconds. It was pretty long, but they did a really good job of managing it, I would say. So, video goes across to the Las Vegas Convention Center. You can see a collapsed view on the left-hand side of the Johnson Space Center. This was what I was just showing you earlier. Then in the Convention Center, we had the satellite feed, which I showed you earlier. It's coming down to a truck, going into a decoder so that it can then be displayed on the screen so that the audience can see what the astronauts are doing and saying. And we're also doing a backup fiber link. Just to be sure, we wanted to this is part of the redundancy that we built into it. We put this fiber in just in case. I think we decided maybe the week before it might be a good idea, which is probably a little bit late, but we got it done. And we didn't have to use it. So that was very fortunate for us. The switcher was here to basically project the 4K onto the screen and also to gather a feed of Sam doing the interviewing. So there were 2 4K cameras in the room, and what you saw was the production basically of bringing those together in 2 boxes, and that's the feed that we would then send out to go downstream and compressed for the full production of the end user experience. So the end users were also getting the production experience that the folks in the room were getting. They were seeing, you would see the person on stage, you'd see the astronaut speaking, you would see the delay, and we would see that as well. Because it was in 4K, it was unbelievable. You saw them doing some of these experiments. I don't know if I'm sure there were experiments at some point in time testing surface tension and things like that, but they were doing it actually to show off how great the visual quality was, how just wonderful the resolution was. And when people were seeing this in the audience, this has been compressed a little bit, but it's still pretty good after several generations of compression. They were very much oohing and aahing, and you could even see some of the things that you may have heard about in 4K with depth of field. So he was doing an experiment where I think it was when he was floating the bubble, and he was just a little bit back from that field of view, and it was a little bit fuzzy, and then it came to blow on it, and you could see him come back into that field for the video folks that are in the room. So what were we doing that day? We had somebody up on stage doing his thing. We had astronauts on their stage doing their thing. And we were in the back with complete and utter calm. No. Actually, I heard it was very calm. But it was terrifying, right? It is a live event. It's not like getting up and doing a presentation where you can start over. This thing was real. And what I'd like to do is introduce our VP of Engineering from AWS Elemental, Khwaja Shams, who also happens to have some background in the world of space, which he can do and introduce and kind of walk through the cloud portion of this. Because at this point, you're going out of the venue and trying to get to the world. So I'll have him kind of introduce your background a little bit and talk about what went down, and then I'll come back up to close it out.
Thanks, Keith. Keith described this as us being calm. I think we can find a better word for it. It was so silent that you can hear your heart racing because you're just scared Why is that? Because we've got this live 4K feed coming in from space. Lots of people around the world watching. It's a historic first. You can't afford to mess that up. A lot of people would be really disappointed. The other thing Keith mentioned, I'll just elaborate on a little bit, is this notion that there's a lot of places in the world where you can't get enough bandwidth to access 4K. Well, turns out conference venues and cellular, those places are more prevalent than you might think, right? So we were encoding this in 4K, HD, as well as much lower resolution so that even if you don't have the appropriate amount of bandwidth, you can still see the experience and still share the experience simultaneously as the rest of the world. So with that, this is us in the back room, just praying and hoping that nothing goes wrong. Can't tell if I went backwards or forward. Sorry about that. All right, so Keith mentioned a few single points of failures, the cameras, the encoder. Everything else we had under our control to make sure that there's so much redundancy that nothing could go wrong. The other good news here was that all the hard part was already done. Getting a light encoder, getting it into space, getting it situated there, and then the communication from space back down to Earth, all the hard part got taken care of for us by the NASA engineers, so we didn't have to worry about any of the hard problems. We just had to worry about what to do when the information comes back onto the ground and how do we get it into the hands of the consumer. So this particular workflow, what's happening here is that you've got the live encoder at the Johnson Space Center, which is feeding the data to 2 live encoders at the Las Vegas Convention Center. You'll notice the level of redundancy here. We had one link here, and then a redundant link going over satellite back to the Las Vegas Convention Center. So we had 2 comm links completely independently coming in through each of these encoders, which then went into AWS, where we ran our packagers. So this is where you're making the transcoded video available for the variety of devices, whether it's Android phones and iOS devices, HLS, Dash for Android, and so forth. And then we had, since we have 2 Elemental packagers running in the cloud, you want to be able to fail over between the 2 of them seamlessly. This is where Route 53's deep health checks come into play that allows us to seamlessly change. If anything were to go wrong on either one of these packagers, you can seamlessly change and switch over to the other one. Meanwhile, it can also do load balancing and have some of the people going to one and the others going to the other. From Route 53, enabling the CloudFront distribution network, our cloud content distribution network to be able to discover where the origin was, it went into CloudFront, which then connected us to all of the devices on Earth. The good news here is that since everything was redundant, we had to make sure that whether it's the communication, whether it's the packager, whether it's the encoder, that we had complete end-to-end redundancy in the whole workflow so that we don't interrupt anything on the viewer experience. We went further redundant because, again, because of AWS, this is really easy for us to get coast-to-coast redundancy. So we ran a Elemental Delta in Oregon in the PDX region, and we ran one in IAD, which is our Northern Virginia region. So we had coast-to-coast redundancy going into this so that we can make sure that this ends up working no matter what goes wrong. And then again, Route 53 allows us to distribute between them as well as fail over between them to make this happen and then get it out back into the devices on Earth. And again, because you have adaptive bit rates, you're able to support any device regardless of what resolution they have available or the bandwidth that is at their disposal of the end users. I'll bring Keith back up.
Thanks, Quadra. So the end user experience. So we've mentioned that anyone could see it. We basically put it up on the AWS website, so anyone that was on a PC could have clicked on it. It was going as well to any device. Probably 600 different devices could have viewed it. Now, not all of those are 4K capable. So whoever had 4K capable devices, it was likely one of the first times that they had ever watched live 4K video. There is definitely streaming video that's available. Amazon Video, you can watch 4K video, but typically it's a video on demand asset. It's probably a movie or a short of some type. And so for many people, it was probably their first experience. And we, in this area, when you're delivering over the internet, you're getting ready for the feedback. Because if it's not going well, you're gonna hear about it pretty quickly. And I was very eagerly looking for the Twitter response and how people were gonna react to it. And I gotta tell you that there was almost no negative response. Maybe they were being nice based on how hard it was to pull off, but I really think it was because of all the redundancy that we built in. And we delivered this to viewers in more than 80 countries. And the reaction was great. I wanna read some of these. So best live stream ever. There's no mic drop in space, which is pretty funny. That NASA live 4K stream was mind-blowing. I finally got my money's worth from this damn curved TV. That stuff was awesome. And so it was a really, really just fun event for us to pull off, and so we were really happy to be able to bring it to you today. One thing that I would say is if you want to see the whole thing, not the 2-minute version, you can just go to Amazon Video and just search live 4K NASA, and you can see the whole production. So it's not going to have the highest ratings because most people are going to that now going, this isn't live, because it happened 3 months ago, and then they're complaining and they're like, it's not live, 1 star. So the stars aren't great anymore. But definitely go and watch it, and maybe give it 5 stars now that you know how hard it was to watch it. Okay. I mentioned earlier that we launched 5 services in a category. So it's a brand new category. We've got compute and storage and database. We've got, in the last couple of years, Internet of Things and artificial intelligence, and now there's a media services category. So services for compression, for live compression, for file compression. If you are in the video industry, check out one of our remaining sessions tomorrow, or you can go back because all of these will be on video. And I'm sure if any of you are super space nerds, which I think a third of you, or maybe it was 80% of you said you were, I'm sure some of the NASA guys will stay and answer some questions if you'd like to, so we can have some time to do that if you do have questions about what we did. But I'd like to thank you for your attention, and hopefully you had some fun and saw what we were able to accomplish with the first 4K live stream from space. Thank you.